In the vast expanse of space, there lie ominous cosmic beasts that have the power to consume entire star systems. Nothing, not even light, can escape the grasp of these ancient entities. In the last half-century, we've made incredible advancements in our understanding of black holes. We've learned that black holes are formed from the collapse of massive stars and have incredibly strong gravitational pull. We also know that they can be found in the center of most galaxies, including our own Milky Way. But even with all these discoveries, there's still so much we don't know about these mysterious celestial bodies. Many astronomers, researchers, and cosmologists have devoted their careers to studying these mysterious celestial bodies. But one question that remains unanswered is, what lies inside a black hole? What secrets do these cosmic giants hold? Join us as we embark on a journey to uncover the truth. The concept of black holes was first theorized by Albert Einstein in his famous general theory of relativity. He described them as cosmic bodies that warp space and time due to their immense gravity. The first theoretical framework for understanding the properties of black holes was introduced in 1915. However, it was German astronomer Karl Schwarzschild who used Einstein's equations to calculate the properties of a black hole and found that it was defined by a boundary called the event horizon, beyond which nothing can escape. But this was not the first time the idea of black holes was proposed. In 1783, an English natural philosopher and geologist named John Michell proposed the idea of dark stars, which he described as cosmic objects with a strong gravitational pull from which nothing, not even light, can escape. His idea was not widely accepted at the time, as most scientists believed light to be a wave, not a particle, until the discovery of light's dual nature as both a particle and a wave. After Einstein shared his general theory of relativity, there was a great debate about whether or not these gravity wells actually existed. But how do we find black holes? One way to detect them is through high-energy X-rays. When a star system or materials get close to a black hole's event horizon, they can reach speeds that are unimaginable. The material spins chaotically around the event horizon before being sucked up entirely, similar to how a kitchen sink works when you drain the water. Due to the high speeds, friction causes the material to burn up with a temperature of 100 million Kelvin. This energetic phenomenon releases X-rays. Scientists just had to look in the right spot in the deep sky. In 1964, astronomers discovered signals of high-energy X-rays from a binary star system. They saw a bright blue star orbiting a strange dark object. It was suggested that the detected X-rays were a result of stellar material being stripped away from the bright star, and thus, the first ever black hole, Cygnus X1, was discovered. Soon after, several more black holes were found in our Milky Way galaxy alone. The most prominent is the Sagittarius A star, which exists at the very center of the galaxy. These are known as supermassive black holes, and it has been found that 95% of galaxies house a supermassive black hole in its core, serving as a glue that holds the entire galaxy together. In 2019, the Event Horizon Telescope accomplished a spectacular achievement. It photographed the shadow of a black hole, which is 53 million light-years away. The photograph of Messier 87, M87, black hole changed our perception of black holes entirely. We were able to see the accretion disk produced by matter spinning and falling into the void. Its luminosity was greater than an entire galaxy's starlight combined. We were literally looking into the deep void of a dark star. The question of what lies within the darkness of a black hole remains unanswered, but there are a few intriguing possibilities. One such concept is that of a Planck star, which connects the theories of loop quantum gravity and black holes. According to loop quantum gravity, there is a minimum size for a black hole, known as the Planck scale. A Planck star is a black hole that has reached the minimum size and has reached the maximum possible density. Imagine a black hole so dense and small that it is affected by the very fabric of space-time itself. Although smaller than the Planck scale, a Planck star is not infinitely small. Due to its maximum density, the Planck star is believed to be stable and does not emit any Hawking radiation, which is thought to cause black holes to eventually evaporate. This process has yet to be observed, as it occurs over immense time scales of trillions of years. It is worth noting that a Planck star is only 10 to the power of negative 10 centimeters in diameter. Another hypothesis is that a black hole could be the home to a singularity. A black hole is compressed into an infinitely small point known as a singularity. This singularity is thought to be the source of the immense gravity that defines a black hole. But even though scientists have a general idea of what a singularity is, they still don't know exactly what it is made of or how it behaves. Another theory is that black holes may be gateways to other universes or dimensions. This idea is based on the concept of a wormhole, a hypothetical passage through space-time that could connect two distant points in the universe. Some scientists believe that black holes could be the openings to these wormholes, allowing matter and energy to travel through them to other parts of the universe. But, as of yet, no one knows for sure what lies within the darkness of a black hole. It is a mystery that continues to fascinate scientists and the general public alike. So, what do you think?